All right, we've got March term. We got to line up, everybody. Let's go. Line up at the door. Here we go, everybody. Let's go. Yes, please. All right, so you're going to follow the sidewalk all the way out to the practice field. Don't cut behind the portable. So it's like this way and then the right through. Keep in mind the testing right there in the gymnasium. We're testing too, our own way. All right, first challenge, high challenge. location, if you can kind of picture the figure that we've been looking at. And so one person to do altimetry, and the camera is right here, so you don't want to be. I'm actually going to change it to this camera. Out to the home. So the altimetry is going to be here. So the first step is, which is like 98.4 feet. So what is 0.4 feet? That's what we forgot. And a basketball too, I realized. If anybody wanted to launch a basketball, you got to bring one of those too. Somebody have a calculator, Andy? Can you multiply 0.4 times 12? So we need to go 98 feet, 5 inches. 98 feet, 5 inches that way. And sort of right here where the last part is to measure that. And so the way to sort of do this is about 20 feet at a time until we get to 98 feet 4. So if I can have one volunteer just sort of stay right here, and then another volunteer sort of walk out this way. There's a do some markers. And then another volunteer please stand right here where my toe is. All right, then you can let go of that. And just kind of like stop that when it gets to your toe here, like kind of line that up. So that's 20 feet. And going down to 20 feet. Now, you're 98 feet, 30 meters. That's it. Right here, black. Now, right here. Right here. Didn't bring that Bluetooth headset. All right, so probably the audio can only pick up if we're sort of like right here. So we just set up the launch pads. That's a former student. They know what's going on. So it's midterms, astronomy. Ah, I hate how this shirt doesn't have a pocket right there. All right, there's markers right here if anybody does indeed need to use the whiteboard for that. Collect some data. Go ahead and choose a rocket. Get a tennis ball, and then so who would like to? And you can do this as often as you want to, okay? Or if somebody else wants to take a turn, so you're going to kind of hold this one here. And remember, just keep your eyes sort of trained on the tennis ball, and this kind of goes for everybody, right? So like this is 0 right here. You're gonna follow it up to the top of its flight once it's at its highest point, and then just kind of hold that there. And then whoever launching is, it's important that they know this launch angle. So if it starts at 90, you have to kind of think about that as 0. So it's like right now it's on either 55 or 125, depending on sort of which way you're reading it. There's two sort of numbers. But if it's going from 90 to 55, it's the difference between that, or the difference between 125 and 90. So 35 degrees. Okay. So if you want to do this first, I'll give that to you. And you just have to kind of be around here. So you're just known 30 meters away. And then let me go ahead and the view here so that now as this rocket launches, it's going to go out of the field of view of the camera. So it's going to be hard for our e-learning colleagues to actually collect it. Oh, I think it automatically picks up there. Oh, yeah, there we go. So, our launch pad.
Yeah. I'm watching it right now. I feel bad for a lot.
All right, so who's up? Who wants to actually? This is their launch.
I guess I'll go.
All right, so choose a rocket there for yourself, and then follow me out to the launch pad here. And then the next person should sort of choose which other rocket they want to use, so that as soon as this one launches, somebody else is walking out to the launch pad with their test. Okay, so grab a tennis ball, grab another rocket. Some of them are already fueled up, but then there's like fuel tanks down there. Then, like I said, there's an unlimited supply on the side of this portable there. Thomas, you can just like set that down, like just somewhere where everybody can see it. If they need to reference that, you don't got to hold that the whole time. All right, and so like whoever, like volunteer first before I just have to go down my roster and say, okay, you grab a rocket, So like let's try to keep this efficiently moving. Unless it goes. Yeah, but okay. This looks like two bottles of capacity.
angle lift off. That's like right there. Start to depressurize pretty rapidly. Those stay airtight. All right, timers, get ready. These stopwatches ready. Altimeter ready. Gotcha, fam. Let's go. Remember, eyes on the tennis ball. 3, 2, 1. God. Wow. Stop. 6:31. All right. So report the time data to Alyssa. Alexander, did you get good altimetry data? What was the angle, or what's it on?
It was 59 degrees.
So 59 degrees. So you're going to record that for your launch angle. Who got good time data? And then remember, the next person can already be walking out, right? We want to get as many of these launches in as we can.
Okay, so what was it? 59
Come on
degrees.
down. Right, and then the next person can kind of decide, okay, I'll grab, like, did anybody, did you collect the rocket, Alyssa?
Yeah.
I think so. Thank you.
Alyssa, did you collect actual rocket?
Yeah, I put it down.
Okay, so somebody can refuel that, right, with the rocket fuel there. So we can grab, another one that's already ready to go.
That went high. Maybe even better than what we did in 8th grade.
Did you go to Johnson?
No, I did that at Central, but I was at Johnson for a bit. I've been around.
Yeah, I remember we did this rockets at Johnson, so I think everyone did the rockets.
Well, yeah. Because I know that my team actually won, and we got some peeps.
Really kind of, otherwise it just keep repeating. So don't pick it up here right now. It's really touchy. Our astronaut on board. Hey, can anybody look at the computer screen and see, do the E-learners have a good view there?
I guess so.
Kinda. You guys are like in the left side.
The camera's up there. Can you like swivel the camera or try to give them a good view? Maybe we'll bring the laptop out.
Okay, you're centered.
Thank you.
No
All right,
problem.
timers, get ready. Altimeter ready. 3, 2, 1. You can't pull too hard. Shit.
Whoa! That might go into the football field.
Well, I didn't get a time for that.
So
Okay.
as long as
I'll go get it.
the angle is okay if it veers off left or right, because we still have basically our 30 meters, but if it goes this way, and we lose that triangle, right? If it goes that way, then we have a longer distance. So sometimes we can't trust the angle data, but the time data should always be pretty good, right? Within sort of human reaction time.
Yeah, I didn't get a time back.
All right, so if you've got a good angle, report it to Gabe. Gabe, record it in your journal, timers, and then the next one up. Come on down. Thank you. You got it, right?
So I wonder how much we should be putting in so we can refuel. Oh, he probably has the caps. I'll go get them. So how much should we be putting in? Yeah, we got refill so people can launch.
Oh, no, I'd say like 3/4. Maybe.
Okay.
Because there's so much
All right.
pressure pulling it right, timers, get ready.
Yeah, it's like a little tiny.
3, 2, 1.
It's like a little tiny.
All right, so that one kind of easier on this one. So you can always record like a qualitative observation with your launch. You could say, you know, veered away from science team, and then that way you know that the angle is really an underestimate of the true height, because really at maximum height there was more than 30 meters, right? And the way the calculation goes is the tangent of that angle times, you know, the distance. So if the distance is bigger, the height is bigger. You can imagine something way in the distance that goes up pretty high in the sky. For you to notice it, that must be, you know, very high up. So the further away it is, right, the sort of higher it goes for a given angle.
Is this enough for the refill?
Yeah, so it's kind of somewhere a little bit between a quarter and halfway seems to be a
Okay.
good place.
I wasn't sure.
All right, so let's have the
Who's next?
remember to let Jonah record his data. So timers that got good data, and then a record of that, a record of that, and then the angle as well.
Oh, whoop.
Yeah. Did anybody time it?
Yeah, I got 5.29.
Do you know what you got the angle or whatever? 42. Thanks.
Someone open this.
All right, timers ready?
Thank you.
Once everybody ready? 3, 2, 1. You can tell, like, if you pressurize a little bit, like I can do that. So I'm getting the fire in the background.
You really gotta yank it. Yeah, I tried to just like pull it a little bit and it wasn't going. So like my whole back. Nah, he said that.
Think about, you know, collecting your data and then data on behalf of our learning colleagues. So we might need everybody to launch like twice. And, you know, once for you, once for them. We have, I think, like 8 or 9 e-learners at home. Still got about 45 minutes until we'll start, you know, head back to the lab. So next one up here.
Anyone want to go next?
Is that you? All right. And then who's on deck? Okay, so you guys be ready to go? So
45 degrees.
Thank
No, it's not. Did you time mine?
Yeah, you got 5.25.
It's crooked, bro. Oh, hell no. I need a different rocket. I'm sorry. Is that a good rocket? Was that one crooked?
I don't know. I'm just make sure I fill it up.
Can I use that one?
Okay.
I'll trade you.
Okay. There you go. No problem.
Here it is. A lot of water.
I mean, it doesn't matter if it's crooked or not,
All right, so
honestly.
this one's, the water level on this one is more than halfway.
Okay,
So
sorry.
No, it doesn't matter. Just keep that in mind as we compare this launch to the other ones that have been less water, okay? Because we talked about sort of the sweet spot of having little inertia, you know, low mass on the launch pad to get it moving, but also having the water in there to create, you know, greater thrust force. So it's a balance between those two effects. so that one veered off this way, right? So the angle is, well, wait a minute. So the value is actually less, but we're assuming it's 30, so we're undervalued. All right, next one up. Make sure as you're going back, you're recording your data, right? And then think about getting our e-learners. It was a small, short launch. I was like, they were here, coming right for me. So I'm like, oh, I'll catch it. I'm trying to catch it too. He just wasn't paying attention. Eyes on the tennis, not looking. It was coming right for me. So I'm like, oh, I got it. Yeah, maybe I should incentivize it.
Oh, it's coming out.
Ready? 3, 2, 1. There you go. Well done.
Yeah, we're gonna need to.
All right, so go ahead.
Is one going or not?
This one's false.
Negligently, you can make a note of it. Like it
need
didn't
to
go
use
all the
that
way to the
hose.
ground. You cut the time short just a little bit.
I didn't even know that this still had a little garden.
All right, now that was a pretty close launch to the launch pad. But if you find that the ball's going way off course, but you feel like I can get it, just call everybody off. I got it. Catch the ball.
Yeah. Is someone timing this one?
Ready? And we're gonna launch in 3, 2, 1.
Oh shit, did anyone get my time?
I think.
Huh? I have to do a rerun, Dr. Schleif.
All right. I think we still have a few that need to test in person. And then we can start asking for volunteers to launch on behalf of our e-learning colleagues at home.
Yeah, I might have to because I didn't get any of my data.
No one got data for your launch?
Oh, I forgot to ask.
I got your you had
What was it?
59 degrees,
59
and then I think
Did anybody get?
And he's got, I think it's just
Okay.
maybe.
All right. So yeah, we can always learn. I think we'll have time to do that. All right. E-learners, if you could type in the chat, is it like the launches and they're just going completely out of frame, or you can't even really appreciate sort of the launch from this angle? I don't know if we need to maybe move our audio-visual equipment closer to the launch out there. For Kyle, or did you get it? Oh, for his launch. Did you get the time data for Kyle?
I don't think so.
Oh, okay. So yeah, Kyle, you have to launch again. Yeah, don't worry so much about you all trying to collect the data through the computer screen. What we're going to do is send colleagues out on your behalf to collect the data. Let me see here.
What was the time?
All right, so we've got 8 e-learning colleagues at home. So what we'll do is we'll just sort of go down the list here, and we'll report. We'll sort of type it into the chat here to use specifically. So I'll just sort of go down the line here. So it's going to be Angelina. All right, who still needs to collect data? I know Alexander, you still need to collect data. So if somebody else wants to take altimetry, so that Alexander can come out and launch, or you could do altimetry for your own launch. But it's kind of fun to go out there and pull the ripcord there. Thomas, I think you still need to go, right? Andres, and then that's it. Okay, so 3 more launches, and then we'll start to sort of go through this. Can we have a volunteer to take over altimetry right here, please?
I mean, I don't mind doing it for my own.
Do you also happen to have another cap in your pocket?
I put them all right here. All right, so you're gonna take over that, Max, or do you prefer to do this for your lunch? Okay, so she'll just somebody else. Actually, I can launch. I haven't had a chance to do that. All right, so this will be Alexandria's, and then Thomas, and then who else? We got Andres. All right, and then we got 8 more. All right. So I'll take. I think we've had a lot of luck with this guy right here. No.
Is it the one that has the symbol on it?
Yeah, I think this one has been giving us the best results there, but we'll.
Yeah. Somebody has the top of it.
Three, two, one. I lost it.
Way to the left.
There it is.
Where?
All the way over there. I'll go get it. I got the next one ready.
All right, so Thomas, do you want to have all the fun of pulling the ripcord here? Do you want to do altimetry? Do you want to be a timer for your launch? You can have any job you want.
I'll pull the ripcord.
All right. So collect your astronaut, your spaceship.
This string.
An astronaut is a tennis ball. Oh, there you go. All right, let's. Altimetry ready? Timer's ready? Three, two, one.
ready?
Yeah, that green one's ready.
And I tend to think like if you're starting time right at the end of the countdown, 3, 2, 1, you almost have to wait and see are they gonna get a good, so I try to tell everybody just pull it as hard as you possibly can, right? So you kind of okay, how hard could it be? But there really is a lot of force sort of holding that in place, so you do have to exert a pretty substantial force to release that. All right, you ready to go? The caps are up there.
All right, you have that thing. Where do I put that in?
You put it in the angle, and then time we'll put in the first one.
Did you get the time?
Yeah, time was 5.5.
5.52.
Yep.
Next rocket ready.
I think that's the last person. Other than
Well, we're still doing the e-learners, So some of us will have to do it for the e-learners.
Ready? 3, 2, 1.
God. To the top of the tower. To the tower. To the tower.
Pretty good. All right. So everybody, I think Kai, you still need to do one more.
No, I got time. I just mentally counted it. I pictured it, and then just gave myself time.
Make a note of that. This was it's like a stopwatch testing the reaction time. If you use 1 Mississippi 2, that might increase the uncertainties.
I can do another one.
It doesn't matter. The idea is that we want to know this physics. So
70
it's
degrees.
to have a
That's
time,
the
but
highest
you
one
do
so
kind of want to see how close does one conclusion agree with the other. And so the best data, obviously leads to better conclusions. All right, e-learners. We're going to start your launches in just a moment here. You want to get one more?
Got 2
I mean,
ready.
I can launch one for the e-learner.
You do have data for yourself, though?
Yeah.
All right, so anybody that wants to, that was fun, I want to do that again, okay?
Yeah,
and on behalf of e-learner, but no one's required to anymore because I'll launch the next 8 if I have to, okay? But if you're like, oh, yeah, I can help you out there, and I do appreciate everybody that's, helping with the teamwork.
Gonna need to refill these.
Ready? Timer's ready? And we'll launch in 3, 2, 1. Anybody get timed out on that one? You got altimetry? All right, so a volunteer that can come out and on behalf of one of our e-learning colleagues at home, first one, and we'll just type it in the chat there, Dad. List alphabet.
Yeah, I got time. 6.43.
Huh?
6.43.
And then 69 for
69.
uh-huh.
All right.
Ready? All right, 3, 2, 1. Your last fight. So like it doesn't hit you in the head.
That was disgusting.
Good data. So that was. All right. What was the altimetry there?
67.
All right. What was the timed out on that one?
6.05.
6.05 seconds and 67 degrees. All right, and so I just typed that into the chat. So that was Camille's data. It's also Camille's birthday. Happy birthday, Camille. And a nice midterm for your birthday. All right, Cody, you're going to be up for your launch.
The green
So-
one is ready.
All right, anybody want to launch this one?
No? All right, I'm doing it.
Come on down.
You got 10 as well?
I've never had that happen. They actually go like that. They say, the rocket for the 25. That's like their suggestion. Explode and consume because like, well, NASA said it was safe. So they suggest after 20. They submit after 20. So it doesn't do that. The worst I think that would happen is just depressurize. Ready? Timer's ready? 3, 2, 1. All right, Cody. That was an impressive launch. Well done. What was the data on that one?
66 degrees.
66 degrees and
6.15 seconds.
6.15. All right. Cody, make sure you record that. Start your calculations. All right, Delilah, you're up. I think, Dave, you're going to launch on behalf. You got the tennis ball.
We use it.
Oh. You didn't bring the cat back.
Okay then.
All right, ready? 3, 2, 1. First bounce counts. First bounce counts. All right, we got good data on that one.
61 degrees.
61 degrees.
5.96.
5.90 seconds. There you go, Delilah. And now we've got Ethan.
Here, I'll go for him.
This will be your launch. All right, you got
I'm just going. I deserve to go again.
Miners ready. 3, 2, 1.
Degrees.
55 degrees.
And
6.3 seconds. Make note, it went off the course.
More
All right.
exercise than I've ever had.
Hannah, this launch is going to be for you. This next one here. Does somebody else want to have another chance to launch here today? Or are we all launched out? I was going to do sure you don't want to go and have all that fun. Go ahead. You take care of this. All right, this is for Hannah. I've ordered at the launch. I think it's like 2 or 3 maybe. We should have plenty of time. I can do another one after you. Yeah.
Yo, what's
Hey.
going on?
Not much, a little bit of rocket science for our midterms here. Did you get down on that?
7 degrees, slightly awkward.
Rockets go up in space. Do they?
Yeah, ideally, we're not quite making it that far here today. We won't have enough thrust generated. 67 degrees and
No, if we had a rocket ship, it'll
Slightly awkward.
explode in space.
6.7 seconds. 67 degrees, 6.7 seconds. All right, 6.7, 6.7. All right. This next one will be for Marley. So check the chat and record your data, e-learners. I'm sending it sort of specifically to you, your unique data. How you want to do this next one here? Ready? 3, 2, 1.
Declare for takeoff. 3, 2, 1. Hang on. Zoom.
All right, what was the data there?
76 degrees.
I thought you played
Time? All right, there you go, Marley. And now we've got Michelle. I think this is our last one. All right, so I'm doing pretty good on time. We've got one final launch that everybody has at least one unique set of data. And then I want to do final launch. So there's a little vocab. Everybody know what penultimate means? Penultimate. Anybody? Penultimate? So we're learning a new word. Penultimate means the second to last. The ultimate, the last, the penultimate, second to last. So this is the penultimate launch. Okay, the penultimate launch right now. We'll use this one. Three, two, one. This one might be the one. Uh, 70 degrees launch angle time.
6.86.
Say that again. 70 degrees. 70 degrees is the launch angle. 6.6.
6.86.
6.86 seconds.
Yep.
There you go. And then that, everybody should have data. Anybody not have their own unique data? So then if that was the penultimate, this will be the ultimate.
It says you the best one.
Yeah, I don't know. I think maybe this one here might be a contender. I don't know.
Okay.
Gemini mission. Gemini mission. Launching 2, 3, 2, 1.
We have to redo that one. Yeah, I think I'm walking a lot of pressure. What if you just run it?
Yeah, I think we might have to retire this one. I think it did have a good run, but over time, the wear and tear there, so it just started leaking so bad. I tend to agree with Kyle. We can't end on that.
Yeah, that was bad.
I'll give him this one.
It's because of the two balls.
And depressurizing. We need that axle line.
Got it.
So just like the twins Gemini, right? Like the constellation, the twins Gemini, the Gemini missions were the first missions where they sent, two astronauts. And those missions were really to prove the technology for the Apollo missions that were going on the moon. So, and then Will Smith was in Gemini Man. I don't know if anyone saw that. I did. I heard it wasn't that great. Not really. It was like his younger self or something. So it was like a double. So again, twins.
And you got the caps?
That's like, what happens if you launch it with cool water?
Cool water?
Yeah.
I don't
There
think
wouldn't
there'd
be
be
room
any
for
difference.
pressure.
Sometimes students want to say, what about soda? Like the carbonation would make, and I'm like, probably just make everything sticky, like it's mostly water anyway. Like,
Yeah, like, no, not pool water, like pool.
oh, full of
Yeah.
water? Well, then there's so much inertia, it's so much mass that it's hard to overcome that. So there is a sweet spot where you need a good pocket that you can actually pressurize the air on top of it, but you still want the water to be sort of the thing hitting the launch pad. So empty isn't the best and full isn't the best. It is sort of somewhere in between. All right, final line.
I went through that. What the fuck?
Three, two, one.
Okay, that is the one.
See, we'll have an entirely new fleet of rockets to launch this afternoon, or not this afternoon. Tomorrow is second and fourth block exams. We'll see how those compare when they're sort of new. All right. What was the data on that one? Just for anybody that wanted a bonus calculation.
Well, the highest ball went 74, and the one that was lower was 68.
That's impressive. They get both. It's like, hey, just like choose one. So 74.68. That's it. That's for the record. 5.66 was the taller one.
That's when they're both down on the ground. Like when the second one was.
Oh, okay, so the first one would have been a little bit. All right, so there you go, everybody. This has been an astronomy midterm. I'm gonna go ahead and stop the recording now, and I'm gonna go